Hello friends, today we will see another experiment number 6 to prepare polystyrene by bulk technique of polymerization. So since this is a bulk technique, there is no other impurity except the monomer and the initiator that are the reactants obviously, and so no other additives there, therefore the product you will get will be quite pure. So aim is to prepare polystyrene by bulk technique. For polymerization apparatus, simply you will need glass beaker, measuring cylinder, watch glass, glass rod, etc. Chemicals that you will be needing are styrene monomer itself and benzoyl peroxide initiator. Both are available in a lab. The lab attendant Jada will give you if you ask him. Theory. What is the theory behind this experiment? Styrene can be polymerized by bulk technique of polymerization. Bulk polymerization and mass polymerization is carried out by adding a soluble initiator to pure monomer in liquid state. The initiator should dissolve in the monomer. The reaction is initiated by heating or exposing to radiation. As the reaction proceeds, the mixture becomes more viscous. You know the viscosity problem of bulk polymerization already explained you. The reaction is exothermic and a wide range of molecular masses are produced. Commercially sold monomers like styrene are added with inhibitors like nitrobenzene, hydroquinone, etc. to check self-polymerization during storage. You know, inhibitors are added so that they don't polymerize by itself during storage only. And these inhibitors are hydroquinone, nitrobenzene, etc. Hence, these inhibitors have to be removed by washing with dilute alkali solution. Otherwise, the expected molecular weight may not be achieved. Properties. It has good flow properties at temperatures safely below degradation ranges. It can easily be extruded, injection molded, or compression molded. It is clear, amorphous, non-polar commodity thermoplastic. Okay, it is thermoplastic, clear, amorphous, non-polar. Okay, easily extruded, injection, compression, all molding processes can be carried out by PS. Uh, Good flow properties at temperature safely below degradation ranges. It has very good electrical resistivity, good chemical resistance to dilute alkali and acids. Measure very simple procedure. Measure styrene monomer 20 ml using a measuring cylinder. Transfer it to a glass beaker and add finely crushed benzoyl peroxide 0.2% by weight of the monomer taken. So 0.2% by weight of the monomer taken. So suppose you have taken 18 grams of styrene, so you will have to add 0.04 grams of benzoyl peroxide. Weighing balance is there, you should be able to weigh it very easily. Heat it in the heating mantle at about 85 degrees with constant agitation using glass cup. As the mixture becomes viscous, pour it on the watch glass. As soon as the mixture will become viscous, you just take it out and pour it on the watch glass. Then dry it for 1 to 2 days till the thin film of polystyrene is obtained. And then you will get a thin film of polystyrene. Quite simple experiment. Result: the experimental yield of polystyrene is observed as so and so. Precautions: initial benzoyl peroxide should be finely crushed and then weighed. So we have already have this finely crushed benzoyl peroxide. The reaction temperature should be properly monitored so that auto acceleration is avoided and the product is conveniently removed at the end. You know the auto acceleration problem in bulk polymerization. That is one of the disadvantages. Monitor the temperature continuously throughout the experiment using thermometer. Yeah, you have to measure the temperature because it is exothermic reaction, right? And you don't want the temperature to cross to a very high level. Pour the mass immediately at the point of viscosity rise. Yes. Polystyrene, you have to keep on checking the viscosity with the glass rod, okay? Polystyrene is used for refrigerator packaging, construction, and in medical industry and stray. Polystyrene can be printed. Polystyrene is used for producing disposable plastic cutlery and dinner usage. License platform remarks: the yield is average, the loss is due to the improper heating, volatile nature of styrene, and improper transfer of fuel. Okay, these are not important. Then this is the kind of setup you will be needing: heating mantle, styrene and initiator in this beaker, and glass rod. Okay, that's it. And now there is some procedure which I will be telling you. It is not exactly word to word same to this procedure, but it will give you a brief idea of how the experiment is done. So just concentrate on this.
Weigh out 4 millimoles of styrene into a 5 ml conical vial and add 2 ml of toluene. Use a plastic microscoop to transfer approximately 20 milligrams of benzoyl peroxide to the mixture. Do not use a metal spatula. Drop in a stir bar. Wipe out the inside joint of the vial. Add an air condenser. Clamp the setup in the water bath. Heat the mixture with stirring for at least 1 hour. A longer time will increase your yield. Make sure to check that your water level does not get too low. It should at least cover the level of the mixture in your reaction vial. Transfer the mixture to a small beaker, using 5 ml of methanol for the transfer. Use a flat-bladed microspatula to stir the polystyrene while pressing the gummy solid against the sides of the beaker to squeeze out absorbed toluene. Pipette off the liquid and add fresh methanol, repeating the process a few times until the solid is hardened and no longer sticky.
So okay, class.